Eric Burgess here, and we've been told to solve this triangle. So let's go ahead and dive right in. So this triangle, we've been given a couple pieces of information that we can use. So we have the angle X, and we also know the side Z, little z. So knowing this, we know that we can use the ratio of this and the hypotenuse to find other things. So that means we could use sine or cosine to get either X or Y. I'm going to go ahead and use sine to do the first one. So I'm going to use sine of 47. Let me make sure my calculator is clearly out of the way. 47.8 degrees. And we know that is to be equal to the opposite over the hypotenuse, which is x over 89.6. So seeing this, we can go ahead and solve for x. So if we multiply 89.6 to both sides, we're going to get x by itself, like this. So now we can evaluate this. We're going to plug in 89.6. We're going to multiply by sine of 47.8. Make sure your calculator is in degree mode. And we get out x is equal to 66.37. Well, here we only had one decimal of accuracy. So we're going to go ahead and just round to one decimal as well. So I'm going to make it 66.4. And that is our x. So this x is equal to 66.4. Now, using the last side, we can use the Pythagorean theorem, or we can use another function. And doing both will allow us to check our answers. So let's go ahead and do it both ways. So we know that 66.4 squared plus y squared has to equal 89.6 squared by the Pythagorean theorem, which means that y squared has to be equal to 89.6 squared minus 66.4 squared. And if we take a square root, we will get y. Now we're going to take y to be positive, but there are technically a plus and a minus. We're just taking y to be positive right now for the case that we're assuming that all magnitudes are positive. You might want to write that down. But just so you know, we could have a y that was going like a negative y. But if we define this to be 0, 0, this would be in a positive direction. It's like a nuancy thing. Just be aware that it exists. So we're going to go ahead, type square root 89.6 squared minus 66.4 squared. Make sure I didn't mistype anything. Looks good to me. We're going to hit enter, and we get 60.159. In fact, we're going to keep to the one decimal thing. So we're going to go 60.2. All right, so now we have y. We have the missing side. And we could get the angle here really easily, by the way. You need to solve the angles too. When it says solve, you need all the sides and angles. So we have the sides, but we don't have the last angle. So we know that all these angles have to add to 180, right? So we started with 180. We took off 90 for this angle, and we take off this other angle, which is 47.8. And we're left with 42.2. So that's the angle y is 42.2. And y is 60.2. Now we can verify y using a trig function with this. So we could use cosine instead, because that will involve the adjacent and the hypotenuse. And I like to use as many of the givens as is possible to minimize any error I may have made with other values I have. So we're going to go ahead and check it by using cosine of 47.8 is equal to y over 89.6. 89.6. So again, we can multiply both sides by 89.6. And these are degrees. I have not been drawing the degree sign. These are degrees. Is equal to y. So y, we expect to get out the same thing, right? And if we do, then we're confident that we didn't make a mistake. So we're going to go ahead and check this. 89.6 cosine 47.8. And if you had your calculator in radian mode instead of degree mode, it'd probably be revealed here as well. And look at that, we get the same thing. And so we get 60.2. We have 60.2 right here. Keep in mind that some of these things we're working with rounding numbers, so there's some rounding error in our thing. So if you get like small discrepancies from using other things where you rounded, well, those discrepancies will be explained by the fact that there was a rounding error. You're not using all the digits of accuracy you had. But that is how you go ahead and solve these triangles. A lot of them are just being clever with knowing which trig functions to use, and they usually have, well, not usually, they always have a ton of ways to check them. Like we could check this value using the sine of the angle y, and use opposite over hypotenuse and solve for y again. I mean, you can verify all the sides over and over. So if you get one of these on your test and you have extra time, you could always go back and just quadruple check it. Make sure that you get every single point this problem's worth. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.